Okay, hello, happy Monday, everyone. Yes, hi Ines. Good evening. I thought it was that morning. Okay, so hello everyone. Welcome back to our October week 2 lesson. Yes, happy Monday. Okay, we have a new student. Yes, hello Sean. I believe you're a trial. Okay, so welcome. Anyway, what are we doing today? We are continuing on our revision. Okay, so hope you have your October notes by now. I know some of you don't have it last week. I hope you do by now. Okay, so today we are doing revision. Excuse me, I'm burping out my dinner. Okay, so anyway, yeah, where were we? Today I'm not gonna repeat on our chapter 4, which is the immunity chapter. Okay, the infectious and non-infectious disease chapter. This one, I'll tell you what, I said this last week. Go home, finish this yourself. Okay, do this yourself. I will upload the answer to the group. Check the answer there. Okay, and before you check the answer, kindly do it. Please don't straight away read the answer. I mean, you can. If you want to lie to yourself like that, then who am I to stop you? So make sure you read and you do. Okay, and before you check your answer. All right, so today we are going to chapter 5. Okay, water and solution. Okay, a very boring chapter. Okay, so we'll start straight with the exercise. So hope you are ready. We have a lot of things to write for today. So get your muscles warmed up because you'll be writing. All right, so number 1, A. Water is a colorless solution with the density of 1 gram per cm cube. That means a 1 cm cube of water, 1 cm, 1 cm, 1 cm. This thing weighs 1 gram. Awesome, isn't it? Okay, we just use water as our. This is how we invented the gram system. Gram, kilogram, everything is based on water. Why water? Because water is the most commonly found thing on earth. So B, the following diagram shows a beaker filled with water. Okay, based on the diagram, explain why water is categorized as a compound. Oh, that's a very good question. So why is water a compound? Because it consists of more than one type of atom. Okay, mengandungi lebih daripada satu jenis atom. Okay, and not only that, they are chemically bonded. Okay, diikat secara kimia. What does it mean? That means water is like this, right? H2O, right? Can you see this bond here? They cut together already. They have chemical bonds in between. This is form 1, right? If they are not chemically tied together, we call it a mixture. Campuran. This is called a compound sebatian. Please don't tell me you forgot this. If you forgot what is a compound and a mixture, then please come back to my form 1. I will shame you, then I will teach you. Okay, because apparently you have a memory of a goldfish. So C, diagram below shows the apparatus setup prepared to decompose water molecule. All right, so this is positive, this is negative. So that means this is positive anode. So this is negative cathode. As you know, water is H2O. H2 is always positive, O is always negative. So H will be pulled to anode because positive attract negative. O will be pulled to anode because negative attracts positive. Okay, so you will see oxygen here. Okay, you will see oxygen here. You will see hydrogen here. We have learned this a few months ago. Okay, I still remember that we learned this in physical class, right? Right before we went into MCO in May. You see, this half year has gone by like it's crazy. Okay, so what is liquid K? Okay, not only we put water, we have to put a liquid K, which is your acid. Not just any acid, let's just say a dilute hydrochloric acid. Okay, acid hydrochloric cair. Now, why you need to add acid? Because water stuck at conducting electricity. Do you know water doesn't conduct electricity very well? Yes, they can conduct electricity, but it's not very well. This is why when your wet hands touches any switch, do you get electrocuted? Do you get electric shock? Yeah, sometimes, but most likely you won't, because water is not very good in conducting electricity. So why must K be added to water? Because water is a poor conductor of electricity. Okay, air adalah conductor elektrik yang lemah. Okay, it is a weak conductor of electricity. So, what now? Acid increases electrical conductivity. Okay, like question like this should only carry 1 mark. Okay, because basically the second point is the same thing. So, acid meningkatkan kekonduksian elektrik. Okay, you can conduct electricity better. Okay, so number 2, predict the ratio of volume of gases collected at P and Q. So as you see, H2O, right? That means O you have 1, H you have 2. So the ratio of P to Q is 1 to 2. Okay, oxygen is 1, hydrogen is 2. This is why your water ratio is H2O, not HO2. Okay, you have 2 hydrogen and 1 oxygen. Very easy. This is a very important question. A very typical chapter 5 question. Okay, put more focus here because this is important. All right, next, number 2, mark for factors that affect rate of evaporation. Okay, how do you dry your clothes? Okay, do you need light? No, you don't. Temperature, yes. Base area, no. Surface area, yes. Okay, you have 4 factors affecting evaporation. Okay, temperature, surface area, humidity, okay, kelembapan, and of course your movement of air. That means pergerakan udara. That means wind. Yes, good. So to dry your clothes fast, make sure your air is not humid, very dry. Make sure you have a lot of movement of air, a lot of wind. Make sure you have high temperature. Make sure you have exposed surface area. That means you open your clothes. When your mom dries your clothes, she opens it, right? Rather than drying it like this. So this is how you dry your clothes. 4 ways to dry your clothes. All right, next B. State true or false for the following statement. Cohesive force between water molecules at the surface can support small insect that stays on water. Yes, true. Okay, let me talk about the adhesive and cohesive force. Okay, cohesive is what we call daya lekitan. Adhesive is what we call daya lekatan. Okay, so you just imagine a layer of water. This is a layer of water. This is the container. This is the wall of container. So between water and water is cohesive force. Between water and the wall is adhesive force. Okay, so cohesive force is between the same thing. Adhesive force is between different things. You see, water sticks to the wall. Okay, this is why when you pour your water out from your bottle, you will see water stuck on the wall of your bottle, right? Because of the adhesive force. Okay, so number 2, the adhesive force between water molecules and cohesive force between molecules of water and the cell wall of xylem allow water to be drawn up. Okay, no. Why false? Because the adhesive and the cohesive, they are reversed. Between water molecules should be cohesive. Between water molecules and cell wall should be adhesive. This question, we have seen this in April, isn't it? Because I remember this question. Okay, anyway. So C, match the following situation to the correct physical characteristic of water. So as you can see, hey, the needle doesn't drop here. Why? Because you have surface tension. Okay, surface tension. Ketegangan permukaan. So what is surface tension? I've mentioned this to you already. If you take your hand and you slap water, it feels painful because water has a tension at the surface there. Okay, it has a force at the surface. That's why when you punch it, ow, it feels painful. Okay, you try and jump, you try and dive into a swimming pool with your face first. You see what happens? Okay, why so angry? Don't know. Maybe it helps you release your anger. I don't know. Okay, so as you can see, the water is just drawn up here. This is what we call capillary action. Okay. Okay, tube is not so much. If you put a piece of cloth here, you will see this thing. Okay, you put a piece of cloth to water. This water will be drawn up. After a few hours, the whole piece of cloth will be wet. That's what we call capillary action. All right, next, thermometer and water. Well, obviously, this is to determine boiling point. Okay, ice is to determine freezing point. Wow, this is so easy, right? Okay, next, number 3. Again, you have the same thing. Okay, positive is here, negative is here. So this is your positive, this is your negative. H2O, H is positive, O is negative. So O will be put towards here, oxygen will be here. H will be put towards here, hydrogen will be here. Okay, so what is this called? What is this process called? This is called electrolysis. Okay, DM is the same thing, electrolysis. So after 10 minutes, there is still no change occur. You know why? You know why? The switch is not on. Okay, I know this sounds really stupid, but that's the answer. Okay, you can say the switch is open. Okay, Swiss terbuka. Okay, terbuka means it is not connected. Okay, so you can say the electrons cannot flow through the circuit. Okay, electron tidak dapat melalui litar. Okay, that means the thing cannot flow through. Yes, hello Raven. We are at page 14. Last week's notes. Have you received yours? Okay, the October notes. We are at page 14. All right. If you need the answer later, I'll go in front to let you see. So C suggests a way to overcome the problem. Close the switch law. Damn, I feel insulted answering this question. So stupid. Switch. Oh, the fan is not on. How can I solve this problem? Oh, voila, professor, you switch on. You switch it on. Wow, awesome. What the hell? What kind of question is this? Adoy. Okay, first and foremost, you won't see questions like this in the exam. Well, if you do see question like this in the exam, that means your teacher is mocking you. Okay, she thinks that if she sets the question too hard, you will be humiliated by the question. Oh, why not I reduce the difficulty? Okay, it's like you are playing online game. You're playing some shooting game. Let's say Counter-Strike. Your enemy is not using any gun. He's just using a knife jumping around so that you can shoot him. It's a pretty humiliation, isn't it? Okay, so anyway, moving on. So D, when the problem has been overcome, we are still continuing on this. So describe the observation in test tube P and Q. So what do you see? How do you know there's a reaction? Very easy. You will see oxygen, hydrogen, right? So what do you see? You will see bubbles. Yay. Okay, so oxygen and hydrogen gas is produced. Okay, gas, oxygen, dan hydrogen dihasilkan. So next point, you will see bubbles. Okay, gelembung. Okay, bubbles, gelembung. So the more acid you put, the stronger battery you use. Let's say this is 2 battery, right? You say, huh, no, screw that. I'm gonna put 20. If you put 20 batteries, okay, first of all, good for you, you're rich enough. If you put 20 batteries, and you put strong acid here, the bubble is gonna bubble like crazy. The thing is gonna blah, 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 blah. That means this reaction is very quick. Okay, I mean, why would you do that? Won't explode lah, but this thing will happen very quickly. All right, so E, complete the table below by stating the test that can be conducted to identify the elements collected. So like I said just now, P here you will collect oxygen, Q here you will collect hydrogen. Okay, I'm just going to write here. So how do you test it? How do you test oxygen? Okay, you use something called a glowing wooden splinter. Okay, wait. Okay, it will glowing wooden splinter. This thing will reignite. Okay, the thing will menyala. Glowing means no fire. That's like a faint fire. You put it inside, wow, when a small fire meets oxygen, they will go boom, even more fire. Because fire loves oxygen. Okay, so kayu, uji, membara, menyala. It just lights up. So the element is oxygen. Okay, hydrogen, your burning wooden, this time I'm using burning wooden splinter. There's a difference, guys. There's a difference. If you are using glowing wooden splinter, that means this thing is like glowing. Burning is you have a fire. So burning wooden splinter gives. Now, when it means hydrogen, what do you hear? You will hear explosion. That will be pop sound. Okay, kayu, uji, menyala, berikan, ini pop. So this is a hydrogen. Okay, pop sound. So this is why you don't play with hydrogen. Hydrogen is not a very pleasant gas to play with. Okay, hydrogen is a very explosive gas. You don't mess with it. All right, moving on. Let's go to number 4. Write true for the correct statement and false for the incorrect statement. What is colloid? Remember what is colloid? Okay, let me talk about solution and suspension. Remember what is this? Okay, larutan dan ampayan. So what is this? Okay, when you take salt, you put in water, you stir, salt can dissolve, right? When salt dissolves in water, that is what we call a solution. Okay, when you take sand and you put it in water, can sand dissolve? No, sand cannot dissolve. You will see a suspension. Okay, so what about colloid? Colloid is halfway. Colloid is in between. For example, milk. Okay, milk is like a solution because you don't need to shake milk. You see, suspension you need to shake because they will sink to the bottom. Like your Milo, if you don't stir your Milo in 5 hours, the powder will sink to the bottom. You will see a very thick brown part at the bottom, isn't it? So that's a suspension. So will this thing happen to milk? No, milk is very uniform. You don't need to shake milk. Milk is like solution. But you see, solution is clear. Solution has no color. Milk is white. So it is also a bit like suspension. So colloid is like a middle fella. They are a little bit like solution, which is like salt water. They are also a little bit like suspension, like your sand water. So they are caught in the middle. So a colloid consists of one solute only. Okay, this is false. There could be a lot. Inside milk, there's more than one solute. Okay, number 2, particles of colloid cannot be separated by filtration. Can you filter milk? No, you can't. So this is true. Okay, you cannot filter milk. You don't just pass milk through filter and then you get clear water coming out. No, you can't. All right, so B, mark for correct examples of colloid. Your shaving cream, okay, your shaving cream. Okay, your ice cream is colloid too. These two are solution. Why? Because they are sugar. Sugar water is a solution because when you take sugar, you put it in water and you stir. Do you see anything inside? No, it's clear. Sugar water looks like plain water. It has no color. It is just like salt water. Clear, no color. Okay, so next, number 5. Oh my god, I remember this freaking question. Why is it here again? Okay, let's try. I should say hate this question. Okay, so compare and contrast the 3 types of mixture, solution, and suspension and colloid using the chart below. A and F has been identified for you. Okay, so colloid, suspension, and solution. So as you can see, oh my god, this is so confusing. Okay, so A is smallest particle size, which is here. Okay, true. Okay, because for solution has the smallest particle size. B can be poured. Okay, solution and suspension can be poured. Colloid, no. Colloid is like your shaving cream. Can you pour shaving cream? No. Can you pour ice cream? No. Okay, C is a mixture. Yeah, there are both 3 of these are mixture, yes. D, no sediment. Solution and colloid, you don't see sediment. You cannot filter them. Suspension has sediment. E cannot be poured, so cannot be poured easily, which is a suspension. Okay. So identify G to L with the guide of the following words. Okay, so let's look at G. Where is G? G is here. Okay, which one fits only solution? Which one fits only solution? I think that would be this one. Does not scatter light. Okay, what does it mean? Does not scatter light, tidak menyerapkan cahaya. That means solution is clear. Solution is clear. Can light pass through solution? Yes. If you take water, let's say this is salt water. Salt water looks like this. When light pass through it, does the light scatter like this? No, they just pass straight through. It's like glass. Okay, it's like glass. It's like fully transparent. So that's your G. Okay, H. H is here. What is between solution and colloid? Between solution and colloid. Okay, they can pass through filter paper. I think this is the answer. Okay, pass through filter paper. That means you cannot filter solution and colloid. Okay, both of these you cannot filter. You filter your shaving cream, you are gonna get shaving cream. You filter milk, you're gonna get milk. You filter salt water, you're gonna get salt water. You don't trap salt in the filter paper because salt is soluble. Okay, it fully dissolves in water. And then next, I is your colloid only. So what is colloid only? I would say this one, medium particle size. Okay, medium particle size. And then next one, J. Where is my J? J is here. What is between suspension and colloid? Okay, they will scatter light. Okay, scatter light. That means light cannot go through them. Light cannot go through sand water. Light cannot go through shaving cream. Okay, your shaving cream is not transparent. So that's J. Okay, K. K is here. What is only suspension? I think there's only one answer here. Largest particle size, like your sand. Can you see sand in water? Yes, you can, because the particle is very big. And of course, what is L? L is only suspension here. There, this one can be separated by filter paper. Okay, K and L can actually reverse. Okay, K and L can actually reverse because they belong to the same circle. Okay, can you understand this? Can you understand this? It's a bit confusing, but it makes a lot of sense if you know what is solution, colloid, suspension. Well, of course, you don't have to be, so exam won't come out something so hard. Mostly they will focus on solution. Okay, solution. Because solution, you have three types. You have diluted chai, you have concentrated pekat, and you have saturated tepu. You're confused. You try and understand, you try and understand this. Okay. So you see, why is K and L these? Because K and L only fits the description of suspension. That's what they mean. All right. So B, give one example of solution suspension of colloid. Okay, this is very easy. Solution is your salt water. Suspension is sand water, sandy water or sand water. Colloid is your milk. This one you understand lah. Okay, this is really easy. Okay, next, number 6. Sam put some soil in a container filled with water. Okay, so soil and water, obviously this is a suspension, ampayan, because the soil cannot dissolve in water. So left to Sam for 5 minutes. Based on his observation, Sam concludes that soil water is a suspension. Do you agree? Yes. Okay, yeah. Why? Because soil does not dissolve in water. Okay, tanah tidak larut di dalam air. All right. Next B. Sam filters the soil water using filter paper. The filtrate is colorless. The filtrate is colorless. Oh, okay. Filtrate is the water. Sorry. Filtrate is the water. Okay, so are there any residue on the filter paper? Yes. Okay, because he filters the soil out. So the soil will be on the filter paper. Can the filtrate be drunk directly? Give a reason to support your answer. Can you drink it directly? No. Okay, tidak. Why? Okay, there might be dissolved substance in the water. So you cannot drink this water even if you filter sand away. The thing still might have salt. The thing still could be salty. You have salt inside because you cannot filter salt. You can filter sand, sure, but there is still salt inside. Okay, mungkin masih terdapat bahan terlarut dalam air. There is still something inside. You can be drunk. Not that drunk lah. Okay, so C. Explain one difference between solution and suspension. Okay, that's a very easy question. So solution is usually clear. Okay, journey. Whereas suspension, it is usually cloudy. Keruh. It looks dirty. You jump into a lake or any river you should see cloudiness because river has sand. Lake has sand. That's why it is a suspension. Okay, unless you go to very clean ocean, like you go to Redang or something, then the one is a solution because it's clear. You can see right in front of you where are all the corals, where are the fishes. That's a solution. It looks clean. Okay, are you guys okay? Are you guys okay? You are surprisingly quiet today. Okay, yes, thank you. Thank you very much. Thanks for responding. I don't know why every Monday's class it's like very deadly one. Vaccine. Oh, you took your vaccine? You took your vaccine already? If I'm not mistaken, 70 something percent of secondary school students are vaccinated now. The first dose 70 something percent. So you should have your sore arm now, right? Okay, 70 something Very, yeah, that's good. That means it's working. Okay, arm wonky, yeah, that's normal. By next 2 or 3 days, you'll be fine. Okay, hey, you took Pfizer, that's good for you. When I took AZ, the AstraZeneca one, oh my goodness, I got so dizzy for like 2 days. That's good lah. That means it's working. Okay, you're not getting fake vaccine. Yeah, there's no such thing lah. Okay, even dizzy. Oh, okay, okay lah. Do you have fever? Because my one thing I cannot stand about AZ is the sore. I get sore throughout my whole body. Every joint is painful. That's the thing. That's the thing about AZ. Okay. Vaccine is vaccine lah. They are all the same. Okay, as long as you're protected. Let's hope that we can move forward through this shit by next year. Okay, I seriously don't want to do online class next year already. We will still do online class. This thing is here to stay, but I don't want to exclusively do online class. Okay, anyway, question 7. So water should be purified and treated before supplying to the consumer. Oh, this is a very common question. State the importance of water treatment. Okay, to purify water so that it is safe to drink. Okay, untuk menurunkan air supaya ia selamat untuk diminum. Okay, menghilangkan microorganism, not only microorganism, Inesh, also sand and whatnot. You want your water to be 99.9% clean. Okay, do you know your tap water is clean? I think I mentioned this last year. This year, sorry. Your tap water is clean. You can drink straight from your tap water. But I would advise you to run a filter first, because yes, our country's water is clean, but the pipes are not clean. Okay, the pipes are 60, 70 years old. It is full of rust. I mean, if you don't mind drinking those rust, okay, you're not going to die, but it's not pleasant. It's going to have a taste. Okay, it will taste like iron because of the rust. I mean, if you don't mind that, it's fine. All right, so 6 steps here. First is filtration, or I like to call it screening. Okay, because this is like a rough filter. Okay, rough filter. They will filter out the big things first, like tree leaves, branches, and whatnot. And then they will do oxidation, okay, or aeration. And then they will do process X is coagulation. Okay, pengumpalan. That means they will add something called alum. Alum will stick all the big sand together so that they become heavy sand, so that they will sink to the bottom at the 4th step. Okay, they sink to the bottom. When they sink to the bottom, your water is now almost clean, and then they will filter it again. So this is the fine filter. Just now was the rough filter. Now is the fine filter to filter all the remaining small stuff. And Y is where they add chlorine and fluorine. Remember, chlorine is to kill all the microorganisms. Fluorine is to make your teeth healthy. Okay, if you don't brush your teeth, just by drinking water, your teeth also will stay good for a few years because the fluorine is to help your teeth. Because last time people couldn't afford toothpaste, that's why they put fluorine in water. Now this thing has no function anymore. Do you have no money to buy toothpaste? Well, come to my house, I'll give you toothpaste. Okay, so number 2, at process Y, chlorine and fluoride were added to the water. Explain the purpose of adding these substances into the water. Okay, so chlorine is to kill microorganism. Okay, membunuh microorganism. So you don't need to boil water. Yeah, sure, you may. So you don't need to boil water. As long as you add chlorine to your water is safe to drink. Just put a filter at home to filter the rust and the sand. Your water is good enough. You don't need to boil it because you're just wasting electricity. Okay, the water coming to your house already has no bacteria. Why would you boil it again? Wasting time. Okay, so next would be your fluoride. This is to prevent tooth decay. Untuk mengelakkan perebutan gigi. Okay, if you are too poor to buy toothpaste, at least you wash your mouth with water. The fluoride will keep your teeth okay. I mean, not to say you have healthy teeth, but at least better than nothing. All right, so C, the flow of chemical fertilizer from agricultural sector to the river will cause the river to become polluted. Explain the effect of polluted water to living things such as aquatic plant. Okay, so what will happen to aquatic plant? So aquatic plant will, okay, the population will decrease. Now, this is a bit to do with chapter 1. Okay, populasi menurun. Now, it means they die lah. Okay, it means they die lah. So when plants die, when aquatic plants die, it will affect aquatic food chain. Okay, mempengaruhi rantai makanan aquatic. Okay, when you affect the plant, you're going to affect the whole food chain. Yes, welcome back. Okay, so you affect the whole food chain. That means when plants die, the herbivores, they will die also. When herbivores die, the carnivore and the omnivore, okay, they will die. Okay, you will affect the whole thing. Why so long part on this question? Suddenly we talk about pollution. Okay, we were just talking about purification of water. Okay, fine. You know what? Okay, so anyway, moving on. Let's go to question 8. How many questions do we have? Hang on. Oh, wow. We have like, oh, we are almost done. Wow, that fast, huh? Am I going too fast? Why is it so little exercise? Okay, lah. If we have the time later, I go back to chapter 4, which is the one last week. Okay, because this chapter is really short. Okay, so A shows two methods of water purification. So this is boiling. Okay, this is filtration. You're asking for it already. Sorry, right is it? Okay, boiling is here. BM is called pendidih. Okay, filtration is penulasan. Oh, I enjoy doing revision. I don't need to talk so much. It makes my life easier. Okay, anyway, I like year-end classes. I don't need to talk so much. Year earlier of the year and middle of the year, it's where everything is very heavy because I need to talk a lot. So anyway, number 2, samples from X and Y were observed under the microscope to investigate the presence of microorganisms. Predict the observations obtained. So X, you can say you have dead microorganisms. Okay, you can still see them, but they are dead. Okay, dead microorganisms. Okay, microorganisma mati. All right, as for Y, okay, microorganisms are moving, okay, or are alive. Okay, microorganisma bergerak, okay, or hidup. The thing is living. That's why you don't just filter your water. Even filtering your water, yes, the water might look very clean, but hey, there is still nasty bacteria inside that you might not know. Okay, so this is why last time okay, chlorination let me tell you chlorination. Let me talk a bit about chlorination Okay, we might just take things for granted today. All water is chlorinated. It wasn't like this 100 years back. Okay, just 100 years ago almost no country chlorinate their water. Okay, so if you get water from any source without boiling it, if you drink it, you might get very sick. You might get a disease called cholera. Remember this thing? We learned this last week, cholera. So before we learn how to chlorinate our water, cholera was everywhere. Yes, from rats and from lalat, they were everywhere. Cholera was a very common disease to have last time. Nowadays, you don't see it anymore. Because why? Because we chlorinate every water. Okay, even you go to some very dirty house, you switch on the tap, you can drink it. Because yeah, it has rust, it's not nice, but at least it has no microorganism. So we tend to take these things for granted, like for sure will happen one ma. But it wasn't like this last time. Hey, last time there's no tap water. You have to collect water from wells. Okay, you have to take it from well. Okay, the perigi, and then once you take it from your well, you have to boil it, all sorts of trouble. So your running tap water is like one of the luxury we have right now that we don't realize. Okay, yes, it's a luxury. Water is a luxury. Okay, for some people. Okay, it's just that we have so much luxury around us that this thing tends to get overlooked. Okay, we take things for granted. So number 3, give one water purification method that can separate suspended particles, dissolve substances, and kill microorganisms. So what is the best method that removes everything? Distillation. This is for sure clean. This is called distilled water. If you drink distilled water, it is for sure safe. Okay, this is why we also call it drinking water. It is completely safe. It is completely clean. It is completely 100% H2O. No salt, no mineral, no sand, no rust, no microorganism, no nothing. Completely empty. All right, so B, this is a water treatment. So this is the first step. Okay, first step. And then second step, oxidation. Third step, coagulation. Fourth step, sedimentation. Fifth step, filtration. And then sixth step, chlorination and fluoridation. All right, so number 1, which tank that would get that work to get rid of unpleasant smell and taste? So which one you will throw away taste and smell? That would be oxidation. Okay, oxidation from oxidar. Yeah, you very love it, you go. Okay, so anyway, what is oxidation? Okay, so when water has no oxygen, okay, when water has no oxygen, you will have bacteria inside, and the bacteria will ferment stuff inside your water. Your water is gonna smell like fart. Okay, yes, it smells like fart. Okay, next time you go to any longkang, I'm sure you have noticed this before. Sometimes you stand nearby longkang, it has that farting smell coming from it. That is fermentation. Okay, your microorganism, your bacteria is breaking down dead stuff in the water. That's why it smells like fart. It doesn't smell pleasant. That's why when we pump oxygen into the water, it oxidizes the smell, so it will get rid of the smell. Okay, so number 2, what are the substances added at P? Explain why the substances are added to water. Hey, they didn't give you an answer. Okay, so they add chlorine and fluoride. Okay, for VM is chlorine and Florida. Florida is a place. Okay, explain the substance. Okay, so chlorine. Hey, this is repeated, isn't it? You write yourself lah. Fluorine is to kill microorganism. Fluorine is to prevent tooth decay. My goodness, why is it repeated? You write yourself. It's the same as here. Oh, yeah. Okay, same as here. Write this yourself. Repeated question. So anyway, C, chemicals such as chemical fertilizer and pesticide can contaminate water. Suggest ways on how to overcome this problem. Okay, so what do? You can educate farmers to reduce fertilizer and pesticide use. The best way is to ask them to use less. Okay, because when you reduce the source of pollution, you don't have all the following problems already. Okay, so mendidik petani untuk menggunakan baja dan I think it's called racun serangga, sorry. Okay, dan racun penggunaan. Okay, to reduce their use. Not to say you cannot use, but you don't just simply spam the thing. Okay, you use it sparingly. All right, what else could you do? Okay, you cannot say filter the water like this. Yeah, they are already filtering it. What can you make it better? So the more you educate farmers, okay, I hate to say it, but it's the enforcement of law. Okay, enforcement of laws against illegal discharge of fertilizer, pesticide. Okay, perusahaan undang-undang terhadap pembuangan baja dan racun secara haram. Okay, please don't say filter the water or whatever. We are already filtering up there. Okay, they are asking you how do you make it better? How do you overcome this problem? Okay, sure, you can don't do these. Okay, but these are gonna use more time to clean the water. Okay, so they're asking you how to reduce it, how to make it better. Okay, the best way is by educating. By educating, because some farmers they don't care. When they spread fertilizer, they will just spam the thing because they don't care about the amount. As long as their plants grow well, as long as their crops go well, as long as they earn money, that's good enough. So why don't you ask them to reduce? Okay, yeah, sure, their crops might reduce a little bit, but if you reduce like what, 20-30% of the fertilizer, then you make the water much easier to clean, much easier to treat. Okay, so anyway, moving on. Oh, that would be the last already. Okay, so since we have 10 minutes left, right? Why don't we go back to the one last week? Okay, because last week we didn't really do much. Okay, let's go to, yes, I want to talk about question 6. Okay, I want to talk about question 6. All right, so this is your vaccine lah. Okay, you are taking your vaccine now, right? This is your first dose, you see? So why do we need second dose? So that you can reach this level, we call it the immunity level. Because if you just take the first dose, if your antibody in your body, if you don't exceed this point, you don't get protection. So they are talking about the third dose now. Do you know that? After they vaccinate everyone in Malaysia, they might go for the third dose. You know why? Because this thing can also drop until here. So they will give you a third dose to further boost this thing. Yes, booster shot, yes. You know this, okay, booster shot. So this is why, okay, not all, some vaccines, they're like this. Okay, for example, hepatitis B. Okay, hepatitis B. You are vaccinated against hepatitis B since young, since you're a baby. But by the time when you hit 20 something, if you're going to do blood test, the doctor will warn you, oh, your hepatitis B antibody, there's no more. Your body has no more hepatitis B protection. You can choose to take it or you can choose not to. Depends on whether you want it or not. Okay, if you're a high risk group, that means you eat raw food a lot, you enjoy raw food a lot, the doctors will ask you to go and get this Hep B booster shot. Okay, because you are most Hep B virus, they come from raw food. Okay, I mean, if you don't eat sushi, if you don't eat like beef, okay, because beef they don't cook it fully. If you don't eat meat like this, then you can kind of don't take this Hep B booster shot because it doesn't really concern you. Okay, but if you just want a peace of mind, go and take it lah, no problem. All right, so this is what we call a passive immunity. When you're gonna snake poison, this is what they give you. Okay, they give you something called anti-serum. Immediately you will get protection, but can you see this thing will decrease over time? Because this thing is not natural. You are getting it from external source. Your body doesn't produce its own antibody, so this thing will decrease over time. So if you need another protection, you need to take another shot. This thing is temporary. This thing is long term. Vaccine is for long term. All right, so write the correct type of immunity. This is your artificial active immunity. How do I know this is artificial? This is buatan, injection. How can injection be natural? Okay, so this is keimunan active buatan. Okay, same thing. This is artificial passive immunity. Okay, you can don't write the artificial since both are artificial, but hey, no harm writing it, just in case your teacher might catch you for mistakes like that. Okay, keimunan passive buatan. Okay, so C, in your opinion, why is the second injection given above? So why give here, okay, to increase antibody above the immunity level, okay, untuk meningkatkan antibody melebihi tahap keimunan. Why must you go above the immunity level? So that you're protected against the disease. So the person is protected against the disease. Okay, supaya seseorang dilindungi terhadap penyakit tersebut. Okay, you must go through the immunity level. But you see, there have been studies saying that after a few weeks or after a few months, they do some blood tests, they realize that for all vaccines, the immunity level is actually very low. So this is why you need to take the third shot, the booster shot. Okay, you might say, so what if after the third booster shot, this thing also can last for a few months only? Then we need to keep taking. We need to keep taking until this virus has no one else left to infect. Okay, which is a long way ahead. Long way. So you just hope that this thing doesn't, you know the virus will evolve, right? That's why you have the Delta strain. You just pray hard that it doesn't evolve into a much deadlier strain. What if tomorrow there's an Eta strain? This thing is like 5 times more dangerous than Delta. Then this thing is much more deadly. This thing makes your vaccine half as effective. Then GG lor. Then we have to invent another vaccine already. Okay, so it's like a race against time. See who is faster. Are humans faster or are virus faster? Okay, you see, this is something very impressive because throughout human history, we have not cured any pandemic before. Okay, pandemic just went away by themselves. You look at the Black Death in 16 something, like a few hundred years ago, there's something called the Black Death, the bubonic plague. it killed like 33% of the population, 1/3 of the population. Okay, and then around 100 years back, there is this thing called Spanish flu. This thing also killed like 1/3 of the population. Okay, why the thing is no more? The thing just went away because it killed so many people. It has no one left to infect. Okay, so until today, you see, this is the first pandemic that we have a chance to win against. This is technology. Last time, there was no vaccine. Nowadays, you think about this, vaccine was invented like around 100 years ago. Okay, and just 50, 60 years ago, to make a vaccine, you will need 10 years. You will need 10 to 15 years to make a vaccine. Now, today, in 2020, in this 21st century, we are doing it in 1 year. From 10 to 1. Can you see how impressive this is? So we actually stand a chance against the pandemic in this modern era, which is very amazing. Okay, now you what did you eat, Ines? Hey, we are at page 8, by the way. Okay, you missed something already. Okay, if you want, you can screenshot. Any one of you need any page to screenshot, you let me know. I'll go to the page to let you screenshot. Okay, by the way, Ines, just now you were here, right? I'll let you screenshot this. Okay, you can screenshot this and then you copy this into your notes later. Okay, and just now, who was it? Raven, was it? Okay, Raven, you can screenshot this one because you came in late. Okay, you can screenshot this, the first page. Okay, your sister already screenshot. Okay, that's good. Okay, so and then of course this is page 13. You came in late, you came in around this time. Okay, so I think almost that's it for this chapter. Okay, today's chapter was a bit easier than last week. Last week one was a bit difficult, which was this one. Okay, go home, you can finish this yourself lah. There's only a few questions remaining, and you can, as you can see, they are almost the same thing. Okay, so you can go home and do it yourself. All right, so don't worry, the answer will be posted in the group should you need to refer to it again. Okay, if you miss something, I'll put it in the group. You can refer to the answer there. All right, so that's it for today. Thank you for coming. Okay, so I hope you had a good revision today. I will go into chapter 7 next week, which is electricity, the electrostatic and electricity chapter. All right, so hope you have a happy night, happy week. I will see you next week. All right, so good night. Bye-bye. Ciao.